folder contains 25 videos of Qbasic tutorial which takes the course from the beginner level to a level that is required by the Department of Computer Science (FUTA) to pass the course with a wonderful grade and to serve as a foundation for your programming thesis. However, beware that this is not to serve as a direct replacement for your school materials given by your lecturers, but just to serve as a complementary guide in aiding your understanding of the concept of procedural languages like Qbasic or Fortran. This video was recorded at schoolfreeware.com and all rights to the use belongs to them. However, the tutorial is being made available by TechGist at no cost to all students. We implore you to follow us on Twitter at TechGist ended with double T and not at TechGist ended with single T. And also you can follow us or like us on Facebook on www.facebook.com/techgist ended with double T. Also you can make requests on more video tutorials relating to IT for academic purposes.
School Freeware's Qbasic tutorial series, Tutorial 1, Getting Started. This is a remake of the original Qbasic tutorial series. Qbasic 1.1 and QB64 is used within this tutorial series. The series is compatible with Qbasic 1.1 and QB64 unless otherwise noted. All code can be downloaded for free at schoolfreeware.com. Qbasic is a simple to learn and teach computer language. It is excellent for showing programming logic and can be made to work on Windows, Mac, and Linux. And the skills learned with Qbasic can be modified for Visual Basic programming. For those running Windows XP and older versions of Windows, you can use Qbasic 1.1 running natively. Qbasic 1.1 is a free download at the website listed on the screen. For those running 32-bit Windows Vista, Windows 7, and Mac 10, you can run Qbasic 1.1 within DOSBox. DOSBox is a free DOS program that is available at dosbox.com. For those running 64-bit Windows, Mac, and Linux, you can use QB64. QB64 is a free download at qb64.net. QB 1.1 has built-in help files, and for those using QB64, you can find the help files located at qb64.net wiki. Once again, all code can be downloaded at schoolfreeware.com. This tutorial will use Qbasic 1.1 running in DOSBox on Windows 7 Service Pack 1 and QB64 running on Windows 7 Service Pack 1. If you're having difficulty saving your source code, you may need to change your Windows preferences or run the program from another location, such as your desktop or documents folder. I'll start this tutorial by using Qbasic 1.1 within DOSBox. Here we have the IDE of Qbasic 1.1, which includes the File menu, Edit menu, View, Search, Run, Debug, and Options. Here we have Help, and if I go into Index, I'll find all the keywords, functions, and commands that I can use within Qbasic 1.1. So for example, I can scroll down, and I'll find our first command we're going to use, which is CLS, and I find that CLS clears the screen, and here's a few examples on how to use CLS. I'll click back on Index. Now let's go to another item. Here we have ABS function. I find that ABS returns the absolute value of a number, and here's a few examples on how to use the ABS. I'll hit Escape and go back to the IDE. So here, I'm just going to make a simple little program. I'll clear the screen, CLS, and I'll print within quotation, hello from Qbasic 1.1, end quotes, and I'll go ahead and run the first program. So I click on Run, then Start. The program prints what I told it to print. Press any key to continue. Now if I wish to save, I'll go to File and Save, and within Qbasic 1.1 you have up to 8 characters for the file name. The file extension will be .bas, which the computer will automatically add to your program. So it's very important not to go over 8 characters. So here I'll just put in QBT1 for tutorial 1. I'll click on OK. And here we have qbt1.bas automatically placed within our file name. If I go over 8 characters, then I could overwrite the file extension and then everything will be confused. Now one of the problems of Qbasic 1.1 is that the internal printing may not work for your system, most likely it won't work for your system, so I can't go to File and Print my source code. What I have to do is open up the folder where Qbasic happens to be, and here I should have QB Tutorial 1, there it is, and then I can open it up with Notepad. So now I can go to File and Print the source code if I wish to do so. Go ahead and close down Notepad. For those using Qbasic 1.1 within DOSBox on Macintosh, you need to use TextEdit instead of Notepad. Here is QB64. Once again, I'll just clear the screen and I'll print out hello from QB64. And while I'm at it, I'll just go ahead and print. This is a second line of text. Once again, when you're printing out text or strings, use the quotation marks. So go ahead and run. Once again, I could go ahead and save, and this time I'll put in QB64 tutorial 1. Computer puts a file extension .bas. I'll just click on OK. Then within the QB64 folder, I should have QB64 tutorial 1. I can right mouse click on it, go to Open With, I'll select Notepad, click OK, and now I can go ahead and print the source code from Notepad. I'll close Notepad down, and I'll close the folder here. A major difference between Qb64 and Qbasic 1.1 is that Qbasic 1.1 is an interpreter. It cannot make its own executable files. Qb64 can make its own executable files by going to Run and then Make Executable Only. School Freeware's Qbasic tutorial series, Tutorial 1, Getting Started. This is a remake of the original Qbasic tutorial series. School Freeware's Qbasic tutorial series, Tutorial 2, Printing Math. These are the math operators used within Qbasic. This tutorial will also use some math functions. The absolute value and the square root will be used. The code used within Tutorial 2 can be downloaded for free at schoolfreeware.com. This tutorial will use QB64 running on Windows 7. First, I'll start off clearing the screen. I'll print some math, 5 plus 10. And you don't need to put anything within quotes because you're not printing verbatim to the screen. Go ahead with some subtraction, 6 minus 5. Print 7 times 6. Print 10 divided by 2. Print 2 to the power of 3. Print the square root of 25. Print the absolute value of -5. I'll go ahead and run and see what we get. Everything checks out pretty good. Qbasic also follows the order of operations. For example, print 5 times 2 plus 10. Print within parentheses 5 times 2 plus 10. And print 5 times, and then within parentheses 2 plus 10. Go ahead and run. And you see that we do follow the order of operations. Also, if I were to go ahead and try to do something that the computer is not capable of handling, like 100 to the power of 100, go ahead and run. We get an infinity, and for those running Qbasic 1.1, you're probably back in the IDE with an error message stating overflow or something to that effect. School Freeware's Qbasic tutorial series, Tutorial 3, Print Formatting. Within this tutorial, we'll use separators. There are two basic separators. One is a comma, which places the output in columns. The other is a semicolon, which keeps the output next to each other. The code for tutorial 3 can be downloaded for free at schoolfreeware.com, and this tutorial uses Qb64 running on Windows 7. First thing I'll do is clear the screen. Then I'll print, within quotation, Qb, a comma, within quotation, tutorial, comma, within quotation, 3. I'll go ahead and run. And by using the commas, I get the output placed within columns. Let's try something similar with semicolons. Print, within quotation, Qb, semicolon, within quotation, tutorial, semicolon, within quotation, 3. Go ahead, run. The strings are smashed together. So what I like to do is fix this by placing spaces before the ending quotation mark. Go ahead, run. Makes it a lot easier to read. And next, with a simple calculation. Print, calculation within quotations, semicolon, and then a simple calculation, I'll have 4 plus 5. Run. And we find that there's a space between the string and the calculation. If I were to change this semicolon to a comma and run again, automatically everything is placed within columns. I'll change it back to a semicolon. Here's the program that we made within tutorial 2. And one of the problems of this type of program is that when I go ahead and run, we find the answers, but we don't see what the math was that made this answer. So I like to put in some text telling the user what is happening. So within quotation, I'm going to put in 5 plus 10 equal, and then a semicolon. When I go ahead and run, now we see what's going on. So I'm going to go ahead and do this for all the mathematics. Okay, I'll go ahead and run. School Freeware's Qbasic tutorial series. Tutorial 4. Variables and data types. Variables hold data in memory, are assigned a data type, the data can change throughout the program's operation, and the data must be the same data type as assigned to the variable. These are the data types found within Qbasic 1.1 and Qb64. String, which is basically text and characters. The integer, which is a non-floating point data type. The long data type can hold a larger number than the integer. We also have the single, which is a floating point data type, and the double, which can hold a larger number than the single data type. Also, please note that Qbasic 1.1 may have a problem with computations involving the double data types, which I will show in just a moment. Within Qb64, you can also use these data types. These are both 64-bit data types for the integer and the float. For a list of data types found within Qb64, please see the website listed at the bottom of this slide. All code can be downloaded at schoolfreeware.com, and this tutorial will show Qb64 running on Windows 7 and also Qbasic 1.1 running in DOSBox on Windows 7. I'll start off by showing the error within Qbasic 1.1 using the double data type. Now let's start by making a variable called x, dim x as double. I'll clear the screen and I'll set x to equal 3.2 and I'll print x on the screen. Go ahead, run, start. We get 3.2 and a bunch of other numbers. If I were to change the value of x to 3.6, start and run, I don't get 3.6, but I get something close to 3.6. If I multiply 3.6 by 10, I expect 36. Instead, I get 35.999. 3.6 times 1,000. Once again, the number is not correct. This does not happen within Qb64, but I would like to point out that on some computers in some situations, the double data type within Qbasic 1.1 is not completely accurate. I'll start with the old school way of making variables. First of all, I'll start with clearing the screen. I'll make a variable called header. Header will be a string, so I'll put a $sign. And I'll make header equal to, this is an example program. I'll create another variable called num1 as an integer. Set num1 to equal 5. Num2 will also be an integer. Num2 will equal 6. Num3 is a long integer, 45,000. Num4, also a long integer, 54,000. Num5, single, 4.5. Num6, also a single, 6.75. Num7 will be a double data type, 56,000.25. And finally, num8 will be a double data type equal to 89,034. I'll print the header. Then I'll print some calculations. Num1 plus num2 plus num3. Print num6 divided by num5. Print num8 plus num2. Last one, print num4 divided by num1. Okay, I'll go ahead and run. And this is the output. Here's the other way of declaring variables. This is also the way Visual Basic works with variables. So I'll start off by declaring dim, and I'll just make num1 as an integer. Num2 is going to be declared as a long. Dim num3 as a single. Declare num4 as a double. And we'll declare header as a string. Okay, I'll go ahead and clear the screen. Header is equal to, this is another example. Num1 will be equal to 5. Num2 is equal to 56,000. Num3 is 45.635. Num4, make that 66,000.5634. And I'll go ahead and print the header. And print, we'll make this easy, num1 plus num2 plus num3 plus num4. Go ahead, run. School Freeware's Qbasic tutorial series, Tutorial 5, Type Mismatch and Other Data Type Errors. All code can be downloaded at schoolfreeware.com. Qb64 running on Windows 7 and Qbasic 1.1 running on DOSBox will be used within this tutorial. The first thing I'll do is declare a variable called title as a string. I'll then clear the screen and I'll place within title the string tutorial 5. I'll then print the contents of title on the screen. Go ahead, run. Tutorial 5 should pop up. It does. Everything looks pretty good. But what if I were to go ahead and try to put a integer within title? So I'll try 25. Go ahead, run. Try again. Doesn't seem to be working. Under status, it says illegal string number conversion on current line. So obviously it needs to have something within quotation marks matching the data type. Within Qbasic 1.1, here we have the same program. This is running in DOSBox. I'll change title so it's 25. Go ahead, run. And within Qbasic 1.1, you'll get a type mismatch error. The solution is the same. The data has to be within quotation, making it a string. I'll go back to QB64, and I'll go ahead and make a new variable. I'll call this variable x, and I'll make this as an integer. I'll set x to equal 50, and then I'll go ahead and print the contents of x on the screen. Go ahead, run, make sure this works. It does. What if I were to try to put in a string with an x? Run. Again, I get an illegal message here under status. Within Qbasic 1.1 here in DOSBox, again, I'll go ahead and create x as an integer. I'll go ahead and place hello with an x, and I'll try to print out the contents of x. Run, and I should get a type mismatch error, which I do. Go back to QB64. Let's play around with this a little bit more. Now x is still going to be an integer, so I'm going to try 50.25. Go ahead, run. I don't get 50.25, I just get 50. Let's try this again with 50.75. Go ahead, run, and I get 51. So obviously, if you try to put in a floating point value within an integer, Qbasic will round. I'll change x back to 50, and I'll make a new variable, y, as an integer. I'll also make another variable called answer as an integer. Okay, so y becomes 25. I'll have answer equal x plus y. So therefore I expect answer to be 75. Instead of printing out x, I'm going to print out answer. Go ahead, run. And instead of getting 75, I get 0. So let's figure out why that is. I take a look at answer and answer here, and I find that I misspelled answer, little typo. Go ahead, run. And now I get 75. So what has happened here when I had the misspelling is that Qbasic has created a new variable with a single data type. And when a new variable is initialized, it's initialized at 0. So this answer variable is equal to 0. Answer is equal to x plus y, which is 75. School Freeware's Qbasic tutorial series, Tutorial 6, User Input. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. First, what I like to do is ask the user to enter in their first and last name. So I'm going to need two variables, one called first name and one called last name. So I'll declare first name as a string and declare last name as a string. I'll then clear the screen, and I'll get the user input by using the command input. Then I'll prompt the user to enter first name. I'll put in a comma, and then the variable first name. So next I need to input, enter last name, comma, and then last name. I'll go ahead and print a line. School Freeware's Qbasic tutorial series. Tutorial 7, If Statements. This is the if statement syntax, the relational operators, and all code can be downloaded at schoolfreeware.com. Qb64 running on Windows 7 is used within this tutorial. We'll start with a simple if statement. I'll first clear the screen. If 5 is greater than 2, then go ahead, print 5 is greater than 2. And if. Okay, go ahead, run. We get 5 is greater than 2 on the screen because the condition is met. If 5 is less than 2, I'll go ahead and print 5 is less than 2. I'll go ahead and run. Nothing is printed out on the screen because the condition is not met, because 5 is definitely greater than 2. Okay, within another program, clear the screen, and we'll try if 5 is greater than 10, then go ahead and print 5 is greater than 10. Else, go ahead and print 5 is less than 10. And if, and I'll go ahead and run. The computer responds by stating that 5 is less than 10. Excellent. Within a new program, what I'd like to do is have the user enter in 2 integers, and we'll check to see which integer is larger than the other. So I'll go ahead and start with dim, and I'll make num1 as integer, and I'll declare num2 as integer. I'll clear the screen, have some input, enter first integer, a comma, and I'll get num1, input, enter second integer, and I'll put that information within num2. If num1 is greater than num2, then we'll print num1 semicolon is greater than, end quotes, semicolon num2. Else, we'll try at this time print num2 is greater than, semicolon, num1, and if. Okay, I'll go ahead and run. Start off with 10 as the first integer and 5 as the second. 10 is greater than 5. Okay, I'll rearrange them. So we have 5 as the first integer and 10 as the second. 10 is greater than 5. Excellent. Let's go ahead and try this with 10 and 10. And it says 10 is greater than 10. That is definitely incorrect. And here's the reason why. We have if num1 is greater than num2, which 10 is not greater than 10, so this is not triggered. But we have an else, which is. So what we're going to have to do is try an else if statement. We'll just make a modification here. So we have else if num2 is greater than num1. Then we'll go ahead and print that num2 is greater than num1. And here I'll just put in an else. And there's only 3 possible situations here. That num1 is greater than num2, num2 is greater than num1, or the numbers are the same. So here within this else, we know that this will only trigger if the numbers are the same. So I'll print the numbers are the same. Okay, I'll go ahead and run, and we'll try this again. Start off with 10 and 5. 10 is greater than 5. Good. 5 and 10. Still says 10 is greater than 5. Good. And one more to try this out. We'll try 5 and 5. The numbers are the same. Excellent. School Freeware's Qbasic tutorial series. Tutorial 8. Select case statements. All code can be downloaded at schoolfreeware.com, and Qb64 running on Windows 7 will be used. I'll make a program that will prompt the user to select a key, A, B, C, or D. So I'll start by declaring a variable called keyPressed. Dim key pressed as string. I'll clear the screen, print 2 lines, and I'll input the user to please enter a key. A, B, C, D, and we'll put the input into key pressed. Go ahead, print blank line, and here is our select case statement. Select case, and then our variable, which is key pressed, case A. So if the A is pressed, we'll print A was entered. Case B, print B was entered. Case C, print C was entered. Case D, print D was entered. If some other key was pressed, we'll have a case else and print some other key was entered. Finally, we have to end select. And we're done with the select case. Okay, I'll go ahead and run. Put in A, says some other key was entered. I'll run this again, and this time I'll use uppercase A. So what is happening here is the computer is case sensitive, so uppercase A is not the same as lowercase a. I can fix this by going to case A and putting in a comma and then a lowercase a. Same thing with B, comma, lowercase b. When I go ahead and run, a lowercase a is now acceptable to the program. But right now I don't care to go through the rest of the program putting in lowercase letters. What I like to do is use a conversion to convert to uppercase. So I'll put in key pressed equals ucase $ key pressed. So what this does is it converts to uppercase. So if the person puts in a lowercase a, we get an uppercase a. If the person puts in, say, an uppercase a, we still get an uppercase a. So the uppercase matches here within the case statements. So I want to go ahead and run. Lowercase a works, uppercase a works, B, C, D, and if I put in some other key was entered. This is a new program. What I like to do is have the computer check a score and determine the letter grade based upon that score. So I'm going to declare score as an integer. Go ahead, clear the screen, print again, and input, enter the test score. Go ahead, print as a spacer, and start the select case statement. Case is greater than or equal to 97. We're going to go ahead and print grade A plus. Case 93 to 96. Go ahead, print grade A. Case 90 to 92. Print grade A minus. Okay, I'll unselect at this time so I can run this and show off what's happening. Enter test score 100, grade A plus. Run, start, 93, grade A. Okay, what I've done is gone through and finished the select case statement. So here we have 93 to 96. It's an A, 90 to 92, A minus, 87 to 89, B plus, 83 to 86, B, 80 to 82, B minus, 77 to 79, C plus, 73 to 76, C, 70 to 72, C minus, 67 to 69, D plus, 63 to 66, D, 60 to 62, grade D minus, case else, print fail, and then the end select. Okay, go ahead, run. Try 59, we get fail. 68, D plus, 77, C plus, 89, B plus. Everything looks pretty good. And there's School Freeware's Qbasic tutorial series, Tutorial 9, While Loop. This is the while loop syntax. For those within Qbasic 1.1, if you get into an infinite loop, press Control break on the keyboard. All code can be downloaded at schoolfreeware.com, and Qbasic running on Windows 7 is used within this tutorial. I'll start off by making a program that will print my name 10 times on the screen. So first of all, I need a counter for the while loop. So I'll make x as integer, and I use x as the counter. I'll clear the screen and set x to start off as 1. While x is less than 11, I'll print my name, and you can use your own name for this. I'll use school freeware. And now I need to increment x, so x equals x plus 1. Remember to end the while loop with a wend, W-E-N-D. Go ahead, run. School freeware is printed 10 times on the screen. And you can also modify this a little bit. So we could have while x is not equal to 11. And this will also print 10 times. To better understand what is happening, I'm going to go ahead and remove the name, and we'll just print the contents of x up there on the screen. So as the while loop loops through, x will change. So we should get 1 through 10 printed up there on the screen. The next little demonstration, what I like to do is have a program that will count down from 10 through 1. So I'll start x off as 10. Have x is not equal to 0. We'll print out x. And make sure that we have x equals x minus 1. And here I'll just print out a line and print blast off. Okay, I'll go run. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. Try a few more examples here. I'll remove this blast off. Let's say I want to print all numbers 1 through 10 that are even. So what I can do is go to x, start that off as 2 because I'm working with even numbers. X less than 11, we'll print x, and x equals x plus 2. Go ahead, run. There's all even numbers. So let's modify for the odd numbers. X will start off as 1, and that's all we need to do. Go ahead, run. There's the odd numbers. And finally, I like to square the numbers 1 through 10. So here I'll print x semicolon squared equals semicolon x times x. And then remember to change the increment to 1. Go ahead, run. School Freeware's Qbasic tutorial series, tutorial 10, do loop. There's a couple of variations of the do loop. First of all, there's the do while loop, which the condition is at the top of the loop. Also the do until with the condition on top of the loop. There's the do loop while with the condition at the end of the loop. And the do loop until with the condition at the end of the loop. If you're using Qbasic 1.1 and encounter an infinite loop, use control break to get out of the program. All code can be downloaded at schoolfreeware.com, and Qb64 running on Windows 7 will be used within this tutorial. I'll start by printing my name 10 times to the screen. So again, I'll need a counter variable. I'll use x as the counter, dim, x as integer. I'll then clear the screen. I'll start x off as 1, and we'll start with the do while x is less than 11. I'll print my name. You can use your own name for this. I'll increment x, so x equals x plus 1, and I'll end the do while loop. Okay, I'll go ahead and run. I can modify the do while, so it's do until x is greater than 10. I can go ahead and run. I can modify this, so we have do loop while x is less than 11. Loop until x is greater than 10. Run. School Freeware's Qbasic tutorial series, tutorial 11, for loop. The for loop syntax is as follows. We have for, and then the counter variable equals the starting position to the ending position. Within the for loop, the computer does something that we tell it to do, and we end the for loop with next and then the counter variable that we're using. For example, if we're using the variable x, we can use a for loop like this. Also, there's a step command within the for loop. So for example, if we want to increment x by 2, we can use step 2 within the for loop. For those using Qbasic 1.1, and if you get into an infinite loop, use control break to exit the program. Also, all code can be downloaded for free at schoolfreeware.com, and Qb64 running on Windows 7 will be used within this tutorial. Once again, I'll print my name to the screen 10 times. I'll start by making a variable called x that I'll use as a counter. X will be an integer. I'll clear the screen and start the for loop. For x equals 1 to 10, print, and here you can use your own name. In my case, it will be School Freeware. And I'll end the for loop with next x. Okay, go ahead, run. That was pretty quick and easy. Go ahead and remove the name and this print x 1 through 10. X equals 20 to 40. Go ahead, run. Let's print out the even numbers by using step 2. Go ahead, run. There's the even numbers. Let's print the odd numbers. I'll start x as 21. There's the odd numbers. Let's try printing backwards from 10 to 1. So I'll start with 10 to 1. And here I have to use step -1. I'll go ahead, run. And there's the numbers 10 to 1 backwards. School Freeware's Qbasic tutorial series, Tutorial 12, Simple Calculator with Input Validation. All code can be downloaded at schoolfreeware.com, and this tutorial will use Qb64 running on Windows 7. Two numbers will be entered into the calculator by the user. So I'll declare num1 as a single, allowing for floating point operation. And I'll declare num2 as a single. I'm using single instead of double because of the floating point problem Qbasic 1.1 has, and I wish to keep this program compatible with Qbasic 1.1. There will also be a menu within this program, so I need to get the user selection, and I would declare dim cell, short for selection, as string. I'll clear the screen, and I'll go ahead and ask the user for the numbers. So input, enter first number. Num1, input, enter second number. Num2, print, and we'll make the menu here. Print, have A for add, print, D for divide, print, M for multiply, print, S for subtract. Input, enter selection. Now put the input in the variable cell. Once again, the computer is case sensitive, so I'm going to work with uppercase, making this program not case sensitive. So I'll put in cell equals the U case, cell. So everything now is converted into uppercase. Next, I'll just print a spacer line, and here I'll use a select case. Case A, go ahead and print. Answer, semicolon, num1 plus num2. Case D, print, answer, num1, divide, num2. Case M, print, answer, num1 multiplied by num2. Case S, print, answer, num1 minus num2. And select. Okay, I'll go ahead and run. Let's see what we get. First number, 45.5. Second number, 35.5. We'll add them together. Good. Run again. 2, 7, divide. Again, run. 4, 5, multiply. 5 and 5, and we'll subtract. Okay, what I like to do now is allow for repeating of the program. So up here at the top, I'll start a do loop. Above CLS, do. And here within QB64, automatically everything is indented for me. I'll go back to the bottom of the program. Loop until cell equals n. Okay, so we're going to do a loop until the selection equals n. Before the loop, print a spacing line. Then I'll input, make another calculation. Yes or no? Now put that input into cell. And here we're working with uppercase, so therefore I got to remember to convert to uppercase. So cell equals ucase cell. Okay, there we are. That looks pretty good. Let's go ahead and run. 45, 45, add. Make another calculation, yes. 56, 10, subtract, make another calculation, n. Alright, that works pretty good, but let's go ahead and run this one more time. 45, 45, add. Say I put in a Q here instead of a Y or an N. It still repeats. Make another calculation, no. So what I want to do is put some input validation here to have the computer check to see if the user had put in a Y or an N. So I'm going to use a do loop. So I'll start off here, do. Loop until cell equals uppercase Y or cell equals uppercase N. So what's going to happen is the computer is going to continue to loop until the user puts in a correct answer, a Y or an N. Okay, go ahead, run. First number 45, second number 45, we'll add them together. Make another calculation, T, 8, 9, N. That works pretty good. Run this again. Now if I put something other than what's in the menu, let's say for example an O, the computer doesn't really make a calculation, this goes straight to the question of making another calculation. I'll just say no. So here I would like to put input validation for checking to see if the person put in an A, a D, an M, or an S. So where we have the input, I'm going to go ahead and put in a do loop. Do loop until cell equals uppercase A or cell equals uppercase D or cell equals uppercase M or cell equals uppercase S. Alright, so this would continue to loop until we get a correct answer from the user. Okay, so I'll go ahead and run. Enter first number, 45, second number, T, Y. I'll add them together. Make another calculation, yes. 75, 75. Let's multiply them together. Make another calculation, yes. 10, 10. 1 here, no. Q, well, let's just subtract them. Make another calculation, no. So using input validation, I can make sure that the user is putting in the correct information. School Freeware's Qbasic tutorial series, Tutorial 13, Random Numbers. All code can be downloaded at schoolfreeware.com, and QB64 running on Windows 7 will be used within this tutorial. I'm going to have a loop within this program so I can get a nice sample of random numbers. So dim x as an integer. I'll clear the screen. And here's the for loop. For x equals 1 to 50. We're going to set the randomization to the timer. Randomize timer. I'm going to print the random numbers, and we'll have 10 random numbers to select from. Next, x. And before I forget, I'm going to put a semicolon after the print statement. This way everything will print next to each other. So I'll go ahead and run. And I got a bunch of random numbers, however everything's in floating point. So what I like to do is convert the floating point to integer. So I'm going to put INT before this randomization right here. So here is the conversion from floating point to integer. Run. I see I get 0 through 9 printed up there on the screen. Let's say I wanted 1 through 10. So 0 through 9, if I just maybe add a plus 1. 0 through 9 plus 1 will give me 1 through 10. Go ahead, run. And I get 1, and there's a 10 there, and another 10, and a couple other ones. So I see that all my numbers are between 1 and 10. Now I'm going to go ahead and change the loop here, so I just have 10 numbers. And I'm going to remove this randomized timer, this as an example, because it's very important to keep randomized timer in with the randomization sequence. Otherwise, something like this is going to happen. Go ahead, run. Everything looks pretty good. Everything looks random. 8, 6, 6, 3, 4, 8, 1, 8, 9, 8. I'm going to go ahead and run this again. 8, 6, 6, 3, 4, 8, 1, 8, 9, 8. That looks like the same numbers. Let me run this again. Yes, those are definitely the same numbers. So we definitely need to put in randomize. Go ahead, run. And now the numbers change every time I go ahead and run. And it's much more random that way. Here I'll go change back to 1 to 50. And let's work with placing the output within an integer data type. So I'm going to declare a variable called rnum, which will be a random number, as an integer. Okay, here instead of printing out, I can just have rnum equal the randomization. Remove the School Freeware's Qbasic tutorial series, tutorial 14, Guess My Number Game. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. I'll start off by making the variables for our game. Dim answer that we have to guess as an integer. Dim our guess as an integer. Declare CNT, the counter for our score, as an integer. And I'll declare the game selection as a string. I'll start by clearing the screen. And I'll start our do loop, which will be our input validation. So we'll start with do and put in the menu between the do loop. So print guess my number game. Print this line of spacing. Print for game A 10. Print for game B 100. Print for game C 1000. Input, please enter a game. And we'll put the input into the variable game. From here I want to remove the case sensitivity, so I'll convert everything to uppercase. Game equals ucase game. And finally we'll loop until game equals A, or game equals B, or game equals C. Okay, let's go ahead and give this a try. A works, B works, C works. And if I put something other than A, B, or C, it repeats until it gets an A, a B, or a C. Okay, everything looks pretty good. Let's move on. Clear the screen and randomize timer. Depending on what the user has selected, we'll use a select case. Game case A, the computer's answer is equal to RND of 9 plus 1. We'll print game 1 through 10. Case B, the answer is equal to RND 99 plus 1. We'll print game 1 through 100. Case C, answer equals RND 999 plus 1. Print game 1 through 1000. And select. Okay, the select statement's done. Everything looks pretty good. I'll set guess to equal 0 and CNT also to equal 0. So here within a do loop, I'll prompt the user to input a guess. Input, please enter a guess. Put the user's guess into the variable guess, and I'll increment the counter CNT equals CNT plus 1. If guess is less than answer, then we're going to go ahead and print too low. Else if guess is greater than answer, then print too high. Else print you guessed my number in CNT counter tries. And if, and then loop until guess equals answer. I'll print some spacing here, and we're going to have to ask the user if they want to play again. Do input play again, yes or no. And I'll put the answer into game, convert game to equal uCase of game, and we'll loop until game equals uppercase Y or game equals uppercase N. Next, what I'm going to do is put in a do loop so we can repeat our game. So I'm going to do up at the top, and at the very end, I'm going to loop until game equals uppercase N. Now the difference between this loop until game equals Y or N is that this has to do with the input validation when we ask the user if they want to play again, yes or no. So this will continue to loop until we get a Y or an N. If the person puts in an N, we will stop the game right here. Okay, let me go ahead and run. First of all, try out the input validation. Okay, input validation works. We'll try game A. Enter in a guess, 5, too low, 7, must be 6 then. You guessed my number in 3 tries. Play again. Let's try H. Yes. Again A. 5, 3, 1. Play again. No. School Freeware's Qbasic tutorial series, tutorial 15, Arrays. Arrays hold a list of variables of the same data type. The syntax is as follows. Declare the array name, the size, as the data type you wish to use. For example, if we wanted to have 5 first names, we can declare fnames 5 as string. Since we created an array of 5, we have 5 placeholders starting with 1, ending with 5. As a side note, within Qbasic, you can start your array at 0 and end at 4, just as you would in C++, but here within this tutorial, we'll start with 1 and end with 5. So if we have fnames 1 equals Joe, this is the first placeholder, so Joe goes into the first placeholder, as you see here. Here the array is filled up with names, and if we put in the command print fnames 4, the computer will go to the 4th place within the array, pick out a Joan, and Joan will be printed to the screen. In this example, we have an array called num. Num is an integer array, and inside, of course, we have 5 integers. Here the command is print num1 plus num3, so the computer will get num1, which is 15, and add it to num3, which is 5, so the computer will calculate and print 20 on the screen. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. I'll start by declaring the array of first names, dim fnames. There's going to be 5 first names as string. I'll also use a for loop later on in the tutorial, so I'll declare x as an integer, so I can use x with the for loop. Clear the screen. Now let's load in the array. Fnames 1 equals Joe. Fnames 2 equals Jim. Fnames 3 equals Jill, fnames 4 equals Joan, fnames 5 equals Jan. I can go ahead and print any name that I wish by print fnames and then the placeholder 3. In this particular case, go ahead, run. Jill comes up on the screen. Let's try print fnames 4 and we should get Joan, which we do. If I wish to go and print all the names, I can use a for loop. For x equals 1, 2, 5, since I have 5 names within my array. Print fnames x. Next, x. So what is going to happen when x is 1? We'll print fnames 1, Joe. Next x becomes 2, print fnames 2, Jim. X becomes 3, print fnames 3, which will be Jill. And so on until we get to 5 and end the for loop. So I'll go ahead and run. And there's the 5 names printed up on the screen. In a new program, let's go ahead and create an array of 5 integers. So I'll declare, I'm going to call this array num. There'll be 5 integers as integer. I'm also going to use a for loop. So dim x as an integer. And I'll show how to sum up the entire array. So I'll need a variable sum as an integer. Go ahead, clear the screen. We'll set num1 to equal 15, num2 to equal 20, num3 will equal 5, num4 10, and num5 is equal to 10 also. Once again, I can print any part of the array to the screen. Print num, for example, 5 should get 10 on the screen, which I do. In the slide presentation, we had num1 plus num3 should give us 20, which it does. So let's go ahead now and sum up the entire array at one time. So I'll set sum to equal 0. And within the for loop, for x equals 1, 2, 5, since I have 5 elements in the array, sum equals sum plus num x. Next, x. Okay, this is what's going to happen. Sum starts out at 0. X is now 1, so we have 0 plus the contents of num1, which is 15. So sum is now equal to 15. Loop, x becomes 2, 15 plus num2, so sum should become 35. Next x becomes 3, 35 plus 5, 40. X is 4, 40 plus 10, 50. X is 5, 50 plus 10, 60. Our loop is done, so the sum should equal 60. So I'll verify this by printing out the answer. Print. The sum is sum. Okay, go ahead, run. And we verified that the sum is 60. School Freeware's Qbasic tutorial series, Tutorial 16, Parallel Arrays. Parallel arrays must have the same number of elements in each array. The data must line up from array to array. We see parallel arrays every day. For example, within a weather forecast, we may see something like this, where we have an array of day, an array of high temperature, an array of low temperature, an array of the condition of the weather. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. Dim day, we're going to have 5 days within our forecast as string. The high temperature, dim high, also 5, as integer. The low temperature, dim low, 5 elements, as integer. And we're going to declare the condition, dim condition of the weather, which has 5 elements, as a string. I'll load the days into the day array. Day 1 equals mon. Day 2, Tuesday. Day 3, Wednesday. day 4, Thursday, day 5, equals Friday. Okay, now that that's done, I'm going to start a for loop for x equals 1 to 5, and I forgot the x, which is no problem. I'll just do that right now. X as integer. Okay, moving on, I'll clear the screen and print day, and there our day array x here. This will tell the user what day that they're entering in the information for. I'll print a spacer and input, enter high temp, high x. Input, enter low temp, low x. Input, enter condition. Condition x. On the for loop with next x. Okay, this is what's going to happen. When x equals 1, it's going to display Monday up there as the day. We'll then enter in the high temperature, placing it within the high array as element 1. The low temperature will be entered within the low array as element 1. The condition will be entered in within the condition array as element 1. When x is 2, we have Tuesday. We'll enter in the high temp as element 2, the low temp as element 2, and the condition as element 2. So you can see here that the arrays are working together. Okay, now I need to print out the information, so I'll clear the screen. And what I'm going to do is just print some headers for the different columns we're going to have. So day, and I'm going to put them within columns. So a comma here, high, comma, low, comma, and then condition. Alright, there's the column headers. I'll print a line spacing there. And for x equals 1 to 5, since we have 5 days, we're going to print day x, comma, high x, comma, low x, and then the condition x. So there's our arrays being printed to the screen, and we'll have next x ending the for loop here. Okay, everything looks pretty good. I'm going to go ahead and run. So day Monday, enter high temperature 85, low temp 68, sunny. Day Tuesday 80, 63, rain as a condition. For Wednesday 72, 55, fog 78, 57, sunny 95, 72, sunny. And there's the weather forecast. School Freeware's Qbasic tutorial series, Tutorial 17, Two-Dimensional Array. Also called a matrix, can be made by arrays running perpendicular to each other. Examples of two-dimensional arrays include a chessboard, items within a vending machine, and a map. Within this tutorial, we'll make a two-dimensional array for a deck of cards. Each element within a two-dimensional array is assigned two numbers. The two numbers correspond with the row and column that the element is in. For example, here we have row 1, column 1. As another example, we have row 1, column 2. Row 2, column 2. And finally, we'll end the two-dimensional array with row 4, column 13. The way we'll make our card matrix is as follows. We will take two arrays, one of suit and one of rank. The array of suit includes the diamonds, spades, hearts, and clubs. The array of rank starts with the 2 and ends with the ace. The matrix is loaded in by combining the two arrays. So here we have the 2 of diamonds, the 3 of diamonds, and finally we will end with the ace of clubs. All code can be downloaded at schoolfreeware.com. In this tutorial, we'll use QB64 running on Windows 7. I'll start by creating the x and y variables, dim x as integer, dim y as integer. The x and y will be used within the for loops. Next, we'll have the array of suit. There's 4 suits within the deck of cards as string. Next comes the rank, dim rank. There are 13 ranks within the deck as string. Here's the two-dimensional cards array. Dim, cards. There's 4 suits, 4, comma, with 13 ranks, 13, as string. Now I can go ahead and load the cards array by doing something like this. Cards 1, comma 1 is equal to D2, which is the 2 of diamonds. Cards 1, comma 2, this is equal to D3, which is the 3 of diamonds. But I'd rather not load the cards array like this. I'd rather take the suit array and the rank array, combining them into the two-dimensional array. So what I'm going to do is delete this. And we'll start by loading the suit array. Suit 1 equals diamonds. Suit 2 equals spades. Suit 3 equals hearts. Suit 4 equals clubs. I have here the array of rank. I'll just copy and paste. You can pause this video at this time if you're typing along with the video. Now let's go ahead and paste the rank in. So here we have the rank loaded from rank 1 all the way to the rank 13, which is the ace. Here's where things get interesting. We're going to load the 2 arrays into the two-dimensional array. For x equals 1 to 4, since we have 4 suits. For y equals 1 to 13, because there are 13 ranks. Cards x comma y is equal to the suit x combined with, which is a plus, the rank y. Next y, next x. So here's what's happening when we start the for loop. X is 1, y is 1. Element 1, 1 is equal to suit 1, which is a diamond, the rank 1. So we have the 2 of diamonds loaded into element 1, 1. Next y. X is still 1, y is 2. Element 1, 2. Suit 1, diamonds, rank 2, so we have the 3 of diamonds. Next y, the 4 of diamonds. Next y, the 5 of diamonds, 6 of diamonds, all the way to where we get the ace of diamonds, which is 13. Y ends. Next x. X is 2, y is 1. Element 2, 1. Suit 2 is spades. Rank 1, the 2 of spades. Next y. X is still 2, y is now 2. Element 2, 2, and we'll get the 3 of spades, followed by the 4 of spades, the 5 of spades, the 6 of spades, all the way to where y is 13, y ends, next x. X is now 3, y is now 1, continue looping until y is 13, y ends, x is now 4, y is now 1, 4, 1, continue to loop until y is 13, y ends, x is 4, so x ends, and the two-dimensional array is loaded. So let's go ahead and print out the array at this time. So for x equals 1 to 4, for y equals 1 to 13, print cards x comma y, and I'm going to also include a space between the elements. So I'll use plus, and then within quotation marks a single space. And I'll end this print command with a semicolon, keeping everything together. Next y, next x. Okay, I believe we're done. Go ahead, run. And there's the two-dimensional array printed out. Start with the 2 of diamonds, all the way through the ace of diamonds. Next we have the 2 of spades, all the way to the ace of spades, the 2 of hearts, ending with the ace of hearts, and the 2 of clubs, ending with the ace of clubs. School Freeware's Qbasic Tutorial Series, Tutorial 18, Read and Data Matrix. Tutorial 18 will build upon the code made in Tutorial 17. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. This is a program made within Tutorial 17. This program makes a two-dimensional array based upon the information found in the suit and rank arrays. What I'd like to do differently with this program is change how the suit and rank arrays are loaded. As you can see, the code for loading in the arrays is long and drawn out. So what I'm going to do is use the read and data commands to shrink the size of the code. I don't need this rank or suit code here. I'll then go to the end of the program and put in data. Here on this data line, I'll put in the information for the suit array. So within quotation, D, comma, S, comma, H, comma, C, comma. In another data line, I'll put in the information for the rank array within quotation 2, comma, 3, comma, 4, comma, 5, comma, and I'll go ahead and enter in the rest of the data ending with the ace. Okay, now it's time to load the suit array. So what I'll do is go here and I'll put in 4x equals 1 to 4, since we have 4 suits. Read suit x. Next x. So what's going to happen as we go through the for loop, x of course will be 1 through 4 within the loop. We're going to read the data line, placing the information within suit x. So as the loop goes through, read will enter in D, then S, then H, then C within the array. Now comes time to load in the rank array. 4, and in this case I'll use Y, since I used Y within the rank here within the two-dimensional array. Y equals 1 to 13. Read rank Y. Next Y. So the read command will continue placing the information within the rank array, starting with 2 and ending with ace. So when I go ahead and run, the program's functionality is exactly the same, but as you can see, the School Freeware's Qbasic tutorial series, tutorial 19, highest and lowest array element. All code can be downloaded at schoolfreeware.com, and this tutorial will use Qb64 running on Windows 7. What I need to do is find the high and low numbers within an array of 10 integers. So first of all, I'm just going to declare numbers. 10 as an integer. I'll need a variable to hold the high and low number. So dim high as integer. Dim low as integer. And this program will have some loops, so dim x as integer. I'll clear the screen and prompt the user to enter in 10 numbers into the numbers array by using a for loop. For x equals 1 to 10. Input, enter, number. And we'll have the input go directly into the array. So numbers, x. Next, x. I'll set high to equal the first element within numbers, and also low is initialized numbers 1, and I'll start the checking process for x equals 2 to 10. The reason why I started x as 2 is that we already have the first element loaded into high and low. If numbers x is greater than high, we know we have a new high number, so therefore high will equal numbers x. Else if numbers x is less than low, then we know we have a new low number, so therefore low becomes numbers x. I'll end the if statement and I'll end the for loop. Next, x. I'll clear the screen. Next I want to print out the array. Print array numbers, and then within the for loop, for x equals 1 to 10, print numbers x, and I'll also put in a space and a semicolon after the line. Next, x. I'll print 2 lines of space, then print the highest number, high and print the lowest number. Low. Okay, I'll go ahead and run. Enter number 2, 0, 9, 6, 7, 8, -1, 100, 104, 3, highest number 104, lowest number -1. School Freeware's Qbasic tutorial series, Tutorial 20, Boolean Techniques. All code can be downloaded at schoolfreeware.com, and this tutorial will use Qb64 running on Windows 7. Unfortunately, Qb64, Qbasic 1.1, and Qbasic 4.5 do not have a built-in Boolean data type that we can use with a variable. However, we can still use Boolean logic with the Qbasic language. This tutorial will show 3 different techniques on using Boolean logic with Qbasic. What this program will do is make an array of integers and have the user enter in the numbers and a number to search for. If the computer finds a number, then a value will be loaded into a variable called found that we can use to determine if the computer has found the number or not. First thing I'll do is declare the numbers array, dim numbers. There'll be 5 elements as integer. Next, I'll declare the search number, search num as an integer. There'll be several for loops, so I'll make x as an integer. And I'll declare found as an integer. I'll clear the screen, and I'll start the for loop for x equals 1 to 5, and I'll have the user input, enter number, and I'll put the input directly into the numbers array. Once again, clearing the screen, I'll have the user input the search number, placing the input into search, num. I'll print 2 spacers, and I'll set found to equal 0. In Boolean logic, 0 is false and 1 is true. So by setting found to equal 0, what we're basically doing is we're saying found starts off as false. So here we're going to search the array for the number. For x equals 1 to 5, if search num is equal to numbers x, then found equals 1. So we set found to equal true at this point. And if, and I'll end the for statement. I'll print our confirmation. If found equals 1, then we know we have found the number. So I can print the number is in the array. Else the number has not been found, so I can print the number is not in the array. And if. Okay, go ahead, run. I'll just enter in the numbers 1, 2, 3, 4, 5, and we'll search for number 4. The number is in the array. All right. I'll run again. 1, 2, 3, 4, 5. And I'll search for number 10. The number is not in the array. Okay. So that's one technique. Let's go work with another technique here. I'll go up to the top and I'll set found as a string. Okay. Here we have found equals 0. I'll change that to found equals within quotation, false, all uppercase. Instead of having found equals 1, found equals true, all uppercase. And if found equals true, all uppercase string, then we set everything to a string, uppercase within quotation marks. Go ahead, run. Once again, 1, 2, 3, 4, 5. Search, number 4. Number is in the array. Run again. 1, 2, 3, 4, 5. Search for number 10. The number is not in the array. Now, one of the problems with using the string technique is that if I was using uppercase for true here, and I put it on lowercase true, went and run, and searched, we have the number is not in the array incorrectly posted up there on the screen, even though 4 is within the array. That is because uppercase is not the same as lowercase. So when using the string method, make sure that you are in the same case throughout the entire program. The final technique will be as follows. I'll set found as an integer, and I'll make two constants. One will be called false, and false will equal 0. Another constant will be called true, and true will equal 1. So here, where we have found, I can have found equals false, and this will not be a string. Found here will be true, and also found here will be true. So found is initialized as false, which also equals 0. So found equals 0. Here, if we find the number, found will equal true, which is also found will equal 1. If found equals true, which is the same as if found equals 1, then we can go ahead and print the numbers in the array. Else we'll print the number is not in the array. Go ahead, run. Search for number 4. The number is in the array. Run again. The number is not in the array. School Freeware's Qbasic tutorial series, Tutorial 21, Preventing Duplicate Data in the Same Array. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. I'll make a program that will hold 4 first names within an array. So first, I'll go ahead and declare fn, which is first name, as a string. I'll declare an array called fnames. There will be 4 first names within this array. This will be created as a string. I'm going to need 2 counter variables for a couple of for loops. Dim x as integer, and declare y as an integer. And I'll declare found as an integer. I'll clear the screen. For x equals 1 to 4. And next we'll start the do loop. Input, enter name. And I'll put the value within fn, and then I'll set found to equal 0. For y equals 1 to 4. If the uppercase conversion, ucase, of fn is the same as the uppercase conversion, ucase fnames y, then we know that the name has been found. So we'll set found to equal 1, and the if statement. Next, y. If found equal 1, then we'll print duplicate names are not accepted. And if, and we'll loop until found equals 0. Once the loop ends, we'll accept the first name and place it within the array. Fnames x equals fn. And finally, we'll end the for loop. Next, x. So here's what's going to happen. We'll start the for loop, and we'll have a do loop until found is false. We'll get the user input, place it within fn, set found to equal false. Within this for loop, we'll check to see if the user input is the same as what's already in the array. If it is, found becomes 1, and then we'll go ahead and print duplicate names are not accepted. Loop back to prompt the user to enter in a name again. If the name is not found, this loop ends, and then we're allowed to place the name within our names array. And then we go to the next x, repeating the process until the loop ends. Next, we'll print out the information. I like to print out the entire array, the names in the array. For x equals 1 to 4, print fnames x. Next x. Okay, I'll go ahead and run. I'll try this out. Enter name Bill. Enter name Bill. Okay, Jim, Sam, Jim, and Jill. Okay, accepted Bill, Jim, Sam, and Jill only once. School Freeware's Qbasic tutorial series, Tutorial 22, String Manipulation. All code can be downloaded at schoolfreeware.com. This tutorial will use QB64 running on Windows 7. Before we get to the string manipulation, there's a few commands that I like to go over. One is the len command, and here I'll just clear the screen and I'll print len hello. The len command returns the length of the string. We have 5 characters within hello, so 5 should be printed up there on the screen, which it is. The mid command can get individual characters from a string. For example, I'll print mid, the string hello, and here the starting point I'll set as 1, and the number of characters I want returned will be 1. So when I go ahead and run, H is printed up on the screen because that is the starting position and 1 character. If I change the number of characters to 2, I should get HE. If I change the starting position, so it starts at character 4, 1, 2, 3, 4, with 2 characters returned, I should get LO printed up on the screen, which I do. The locate command locates an area on the screen and moves the text cursor to that point. For example, locate 1220, print hello. Go ahead, run, and we find that hello is printed at 1220. We can have a little fun working with strings using the len, mid, and locate functions. So here is an example of printing user input vertically on the screen. So I'm going to declare WRD, which is short for word, as a string. I'll declare X as an integer. Since we're going to use a for loop, I'll clear the screen and input, enter word from the user. Put the value within WRD. For X equals 1 to the length of the word, we're going to print mid, the word, comma, X, comma, 1. Next X. Okay, I'll go ahead and run. Enter word, hello. And there's printed vertically on the screen. I like to modify this program now so the word will print backwards vertically on the screen. For X equals the length of the word to 1, step -1. Okay, I'll go ahead and run. Hello. And hello is printed upside down. What I like to do now is print a word up there on the screen that's at an angle. So I'll make modification, first of all, to the for loop for X equals 1 to the length of the word. The locate command, X plus 10, comma, X plus 10. We'll put in that coordinate. Now go ahead and run. Hello. And there's hello printed up there on the screen at an angle. School Freeware's Qbasic tutorial series, Tutorial 23, Palindrome Program. A palindrome is the same backwards and forwards. Some examples include noon, 1991, Bob, and Redder. All code can be downloaded at schoolfreeware.com, and this tutorial will use QB64 running on Windows 7. Start with the word that the user will enter into the computer. I'll declare WRD as string. WRD is short for word. I'll still declare the reverse of the word, REV, WRD, as a string. And I'll declare X as an integer. I'll start by clearing the screen. I'll input, enter word, and the user will enter in the information and the computer will place the information within WRD. Now we have to reverse the word that the user has inputted into the computer. For X equals the length of the word to 1, we're going backwards through the word, step, -1. The reverse word is equal to the reverse word combined with mid word, comma, x, comma, 1. Next, x. And that will reverse the word that the user has inputted into the computer. I'll then go ahead and print line of spacing and original word. And since we haven't used L case, I'll use this at this time. So I'll put everything into lowercase, L case, word. And I'll print the reverse word. L case, reverse word. If L case of the word is equal to the L case of the reverse word, then we know that the word is a palindrome. Print the word is a palindrome. Else, print the word is not a palindrome. And if. Okay, I'll go ahead and run. Let's test this out. Enter word, noon. 1991. Fred. Hello. And one more. Rudder. School Freeware's Qbasic tutorial series, tutorial 24. ASCII program, separating letters, numbers, and other characters. All characters are assigned an ASCII number. For example, lowercase a is assigned 97. All code can be downloaded at schoolfreeware.com, and this tutorial will use Qb64 running on Windows 7. First of all, there's two functions that convert ASCII values into characters and characters into ASCII values. I'll clear the screen and I'll print CHR $97, which converts an ASCII value, 97, into a character. I'll print ASC, then within quotation, lowercase a. And this will convert lowercase a into an ASCII value. So when I go ahead and run, we get lowercase a on the screen and 97. We'll use the ASCII character conversion within our program that we're going to make now. I'm going to need user input, so I'm going to declare UI, which is user input, as a string. I'll declare a test character, TC, as a string. The test character will hold a character that will be used to check to see if the character is a letter, number, or other character. If the character is a letter, we'll place it within LC for letter characters as string. I'll declare NC, number characters, as string, and I'll declare OC, other characters, as string. There will be a for loop within this program. I'll declare X as an integer. I'll clear the screen. Input, enter, string, to separate. I'll put the value within UI, user input. For x equals 1 to the length of the user input, we'll get the test character, TC. So TC equals mid, the user input, x, in one character. Now we need to check to see if the test character is a letter. So if the ASCII conversion of our test character is greater than 64, and the ASCII conversion of our test character is less than 91, then we know that the character is uppercase. Now we also have to check for lowercase characters. I'll put in an OR statement. So the ASCII conversion of our test character has to be greater than 96, and the ASCII conversion of our test character has to be less than 123. Then we know that the test character is lowercase. So here we have if uppercase or lowercase, then we know that we're working with a letter. So then we'll place the character within LC. LC equals LC plus TC. And the letters are done. Else if the character is a number, the ASCII conversion of our test character, if it's greater than 47, and the ASCII conversion of our test character is less than 58, then we know that the character is a number. The number characters are equal to number characters plus TC. Else, the character is something other than a number or a letter. OC equals OC plus TC. And if. Next X, and our for statement is done. Now comes time to print out the output. Print letters, LC, print numbers, our number characters, and C, print other, OC. Okay, go ahead, run. Capital A, capital Z, lowercase a, lowercase z, 109, bunch of other characters, H, J, O, capital P, bunch of numbers, as you see there. Enter them in, and perfectly separated.